Hello everybody and welcome back to the channel. Today we're going to take a look at the AirBlade UAV Macaron. Featuring the AirBlade 1104 10,000 kV motors, 10 amp Cicada ESC, F4 flight controller with OSD, a Redcon R720X DSM receiver, eSheen TX01, I took off the antenna, Racer Star 1935 props. It weighs 73.1 grams. Prop guard is 2 millimeters, 3 millimeters wide. Landing feet are 2 millimeters. I think the bottom plate's 2 millimeters too. Of course, I've been flying with my LiPo batteries. These two you can buy in the US. The 600 milliamp battery weighs 31.4 grams. The 430 milliamp battery weighs 25.2 grams. Full parts list in the description down below. Okay, the first thing I have to tell you about this machine is I had a lot of fun flying it, but I mainly flew it outdoors, and mainly because I found it a little bit of a challenge to fly inside. I think at the weight, when you start pushing 100 grams or a little bit more, you have more inertia in the corners and it's harder. You have to get a little bit more angle and pitch in order to get yourself to slow down for corners and whatnot. And I think I also struggled to find just the perfect camera angle for myself. I tried straight up and then I was bored with that flight. So the inside flight footage you're going to see isn't my best or most exciting, but it does prove the point that you can fly these around inside when your weather is bad. I think what this is really suited for is for someone who wants to get started and wants to build something and doesn't want to be changing out props all the time. Although you can get sticks and stuff down in here and your props will get mangled up. More so than any of the other guarded brushless builds that I have, this one tended to just bounce off of stuff. Oftentimes, especially when you would hit something at a wall, it would get vertical like this and suck itself to the wall. If you let off the throttle, it would come back down flat, and if you saw that happening in the camera view, you could catch it and then fly out of there, which I thought was remarkable because I've been flying a lot indoors and I've smacked into a lot of walls, and usually when you get vertical up against that wall, it's lights out. You gotta crash, you gotta go down, you gotta reset, get yourself back upright and take off again. The build in this case was a little bit of a challenge, but it had really nothing to do with the frame. And I've got a full build video so I'm not going to talk about all the ins and outs of the build. But as you can see, we would have been better off building this using something like this, which this is a stack off of Banggood. And I'll link it down below if you're interested in seeing it. But this would allow us to run full 2-inch props. And you can see, even with these 1935s, I did somehow manage to mangle up my connector down there. And probably showing it in a video up here. I kind of repaired these wires and put some liquid tape on there, and it seems to be fine. And there's just nowhere in this stack to tuck these wires. I couldn't get them down in there. You can see that even this top board isn't actually completely level. I wonder if that came from a crash. The one tip I can give you about building these, if you find that you can't arm or that you can't calibrate your ESCs when you're using a 4-in-1 with a flight controller, is that you might have to do what I've done here, is just tack on to the pigtails. These are the battery leads down here. The wires run out the back. So just tack on a couple little wires and then run them to the power or the battery pad on the flight controller, and that generally remedies those problems. Now, if there's something else wrong with the flight controller and you can't calibrate ESCs or you can't arm or something like that, the video I just did on the CS110, I talked about how I have 4 of these F4 flight controllers, and this is one of 2 that I actually have running. I really like the camera mount. I think it's a little bit heavy, I think, but it really does a nice job of holding the camera in place. It also, you can't hardly see it here, but this 3D printed piece goes well up into here, and then you just take a piece of heat shrink and you put it over the top and shrink it down, and it keeps everything in place real nice. I really enjoyed that. I did break my lens, and you can probably tell I've glued it back in place. The lens, the insert section just came loose. I've never had that happen before, but I put it back together, and it seems fine. At first I thought I had a spot, but I think that was just dirty goggles. I think using a smaller receiver than this would be a good idea. This is that Redcon 720X or R720X, and it works just fine. It's just a little bit big for this tight of a build. I think I'd have been better served using my typical satellite, but they seem to have become more expensive and a little bit harder to get. I'm noticing you can only buy 1 or 2 at a time now. I did another build already, and I've been kind of flying that one around, and I used the Eachine SP09X. It's also DSM-X compatible receiver, and it's much smaller. I would say it's about half the size of this one. I think they say it comes in at 0.7 grams. I haven't had any problems with range. It's got a nice flexible antenna wire. I haven't had problems with that antenna wire getting loose or anything, so I think I would probably use more of those and less of these Redcons. But I had one, it would fit in, kind of, so I used it. You can see over on this side, I did a little trimming here in order to be able to get my antenna tightly tucked, and even with that, again, somehow, I don't know how I managed to do it. Well, I think those blades are off, maybe. I don't know how I've managed to do it, but I did tear an antenna out too. So I had to repair that as well. You've seen how I do the OSD. If you haven't seen how you can connect a camera like this to an OSD, I'll put a card right up here for you. It's pretty simple. It doesn't take a lot of effort or a lot of fine soldering skills, so you should be good to go there. Overall, I've had a good time with this. I'm very pleased that I built one. I think Mr. AirBlade has done a great job on these motors. At one point, I was running this outside, and we had got a spot of good weather, and I had like an hour. And I think I did 6 batteries back to back to back to back just as fast as I could. Not because I wanted to go fast, but I was just having fun, so I kept pumping in batteries. This thing probably didn't have more than a minute off between batteries at most, and I just kept running them. And the motors were warm, but not as warm as I expected after I thought about what I had done, because the last little bit, I'm actually doing a pretty hard orbit around one of the center trees, and you probably have seen that already. And I was running pretty high throttle to get that nose down, because my camera angle when I'm flying outside, it's somewhere around like that. So in order to do that orbit, you know, I'm pretty pitched down and coming around that tree, so I was running pretty high on the throttle. And that was, when I got done, the beeper was just buzzing and it was going crazy. So that was probably pretty hard on it. But the motors are doing great. They're still running great today. I was just flying this again outside with the other vehicle out front this time. The one tip I can tell you, that if you're not going to watch the rest of the video, you do have to kind of finesse these legs in. And you want to get this part hooked first. This is how I found it to work for me. You get this part hooked first, and then you get this part put in, and then you pop it down. Generally, once you get it in, it'll stay. But you may, you don't want to put the zip ties on until you get all 4. And of course, as you get down to the last one, it becomes more difficult. But finesse it in. You don't want to use brute force. Wiggle it. back and forth, kind of use itself to shave a little extra room to get down through there, and you can do it. I would say stock up on some, if you're using 1104 motors, and maybe you already know this, if you're using 1104 motors, typically the screws that come with the motors don't fit these thick hub very well. I ordered some M2, these are M2 screws, and I ordered a set of 50 off of eBay of the 7mm, and those work pretty good. I don't want to get too deep inside the bell and cause any problems with my motor, so I use those 7mm. Okay, we'll take another look at a flight, then I'll have the build video after that. If you have any comments or questions, please leave those in the section down below, and thank you for watching. Okay, we have all our kit contents laid out, and I should highlight probably the most important thing. It's a little bit different than what we've done in the past. This is an F4 flight controller with an OSD, as you can see printed right there, hopefully. There we go. So we've got an extra large processor there on the top that should allow us to run 8K on our loop times, and it should be fine. We have all the different connections here. I won't go through all of them, but I'll give you a look at the board. You can probably find a better picture on the Banggood website. Things are listed fairly well on the back of this board, though. But, you know, with any flight controller, we always have to worry about how will it hold up. So we'll be giving that a go, and I'm sure to crash it a whole bunch. But, so we have our Cicada 10 amp 4-in-1 ESC that runs 2 to 3S. This is an indoor model, so we'll only be flying 2S. 3S would probably be much too much. And so I am going to tack on a couple of spare wires that I have. I could cut these off of here if I wanted to. And I'm going to tack these on to the battery leads. And then I'm going to run them up into these positions to supply voltage, because this flight controller does say it can run 2 to 4S. So we should be fine there. It's also got 3.3 volt power spectrum receiver as well. So your receiver agnostic here, you can do any receiver you want if it runs 5 volt or 3.3 volt. I have plugged the board in, and I make sure it works as we should always. I believe this is pronounced Macaron or Macaron. I'm not sure. I'll put it on the screen. You tell me. We have, this is from AirBlade, as we see here in front of us. We also have some AirBlade motors. I've been looking to try these out. These are 1104 10,000 kV motors. And they're this lovely green here. And you can see it's got a hole pattern here for props that take screws. So we've got 4 of those over here. Camera mount, also from AirBlade. Should fix right on here. It's mounted perfectly for a rotated flight controller. And this might draw your attention here a bit. This is the TX02, so it's 200 milliwatt. It takes a little bit more juice, but it might look a bit foreign to you because I have this yellow wire on here, and then I put a whip antenna on it. Normally this comes with a circular polarized, and so I took that off and put this on. And that's pretty simple, and I think instead of going through it here, I have another one in my bin. I'll make a separate video on how you do this, and the reason why I have the yellow wire is that I want to hook it up to the OSD off the flight controller. And as you can tell here, it's the same pin. And all I've done, if you don't want to watch the other video, is I took a tool and I snipped that part off. I don't know how well this is going to come through video, but if you look real closely down in there, you might be able to see a bit of copper, but that's not actually the pin. So I'll verbally to walk you through this. So I powered on the camera just using a little tiny whoop LiPo and made sure the camera worked. Turned my goggles on, make sure I had a picture. So after that, then I snipped the cable, powered it back up, make sure I didn't damage anything, and at that point I had all black. And that's one thing about your goggles. If you have all black, it generally means you have an image issue or a camera issue. Static means you have a VTX issue. So I knew the VTX was still transmitting and I was on the right channel because I was using the band scanner. So I knew that I had separated the video connection from the camera to the VTX. From there then I tacked on this and plugged it in again to my battery, turned my goggles on, and now I had an image, so I thought, well, I'm good to go. So in order to connect this up, what I'll do is I'll just cut this wire and then I'll connect it to the video signal in and out on this board, and I should be all set. But we'll go through that a little bit. This will be a little bit of an abbreviated build. Got a couple of TPU printed spacers. Picked these up from AirBlade as well. A full disclosure, I did buy a lot of this stuff from AirBlade. I spent about $115 or something like that. And then he threw in a couple extra frames, which I'll get to here shortly. But this was one I'd already had, and I just hadn't gotten around to the build. And I had seen on Facebook he was talking about his motors, so I wanted to give those a try as well. I was also short on 10 amp ESCs, all-in-ones. I like the cicadas. I've got a couple of 12 amps I'm going to try as well. And those would come on later builds. But I wanted to build this unit with many of the AirBlade parts, one-stop shopping. You can pick these up and they will be shipping out of British Columbia, so that's something you should note if you're in the States. That shipping is substantially quicker than ordering from Banggood or GearBust or any of our Far East retail shops. So it comes from Canada and gets there relatively quickly. Okay, what I'm going to do is I am going to get my ESC mounted up, and I'm going to get my motors mounted up, and then we'll come back and we'll start to solder everything up. I'm not going to go through any motor reversing. If we come to it, I may remap motors. Say we got the pinout that just doesn't work with these flight controllers. Because this comes with Betaflight 3.1, we can use the resource variable to remap our motors so we get them in the proper alignment. Okay, I'm going to get reorganized and then we'll go. Okay, as you can see, I've mounted up the motors. Just 2 little screws in each one. You can use thread lock on those in order to help secure those a little bit. You can also see I've shortened the wires for motor 2 and motor 3. And motor 3 is going to go right here, and then we'll do motor 2 right there, motor 1 right here, motor 4 back over here. So that's why I have the wires routed through here. Also, you can see where I've tacked on a couple of leads
to go to our flight control. So let's go ahead and tin these up and solder those down. Go ahead and do a few pads here. This is pretty basic stuff. Want to make sure you get the pad hot and add your solder to it. Pad hot, add the solder. This one I can't hardly see. Looks like I got it though. So you would do that for both sides. Now I'm going to do the difficult one first. The one that, well, yeah, I'll do the difficult one first. So this is motor 1 up here. And you can see that's labeled A1, so we won't have to actually resource map, but you could do them as short runs. And you could also take these wires up over the top. I choose to have it underneath. And you can see I've got my battery strap in already. And we've rotated everything 45 degrees. That's something we'll have to tend to on our flight controller because we're going to be flying right that way. Let me see if I can get a hold of a couple of these wires and get them bent so we can tack them down. These motors do have really nice flexible wires. They're not brittle or tough. Much easier to work with than, see, the Racer Star. You can tell this one's almost a little short. But I think we should be able to get it right there if I can get a hold of it. Okay, we got that one. And again, I'm not paying attention whether this is straight through or rotated. That one's a little long. I don't think we need that much hanging out. I'm going to trim that off. Because we can use the BL Heli app. Hopefully you used that before. If not, it's pretty straightforward and simple. First time can be nerve-wracking, but plug in your USB port, click connect, add your battery, click read setup. It should read your ESCs, and then you can pick which motor you need to change the rotation on. Boy, that one's long too. Let's trim it back. Always give them a pull test. Alright, there's one motor. Let's go ahead and rotate this. We'll tack these down. You'll note these a little bit long because I plan to use a loom band to keep these wires down so they don't wiggle around much. I think I'm actually going to turn things all the way around over here. I'm using blue tack underneath there to keep it steady. Try to keep from burning my nylon standoffs while I'm at it. There's one. Two. Three. Now you do the other side like I did this one, or we'll be on to setting up the flight controller. Here's a quick shot what I did with my little leads off of the ESC. I just soldered those right on. We got our negative and our positive. Used a little bit of blue tack back here to hold things in place. So all I have to do is fish these things out. I'm going to keep these wires back here separate. Let's see, can I get this plugged in before we go on to the next step? Yeah, it shouldn't be a problem. There we go. And I'll just take a tool like this just to kind of push everything under here a little bit. Well, that didn't work great, but my fingers will assist. Let me line it up. And oh no! This flight controller uses 2.5 millimeter, but I can solve that with a drill bit. I'll do that and we'll be right back. A couple things I have to sort out here. You can see the prop here hits. That's no good. So it looks like I need to raise the slightly raise the flight controller, which isn't something I like to do. I like to keep a low profile, but looks like I'm going to have to bring the flight controller up a little bit, so I'll have to use another nylon standoff to bring that up. If I could lower it, I would, but I just don't think there's room underneath to run things. We got our battery strap, we got our motor wires. I could run the motor wires through here and across. I'm going to do some dry fitting, and then we'll come back and I'll show you how I got along. Okay, despite all my wranglings and getting this profile down just as much as I can, you can see I've used a couple of the TPU spacers that I think they're about 3 mil. If I have the prop way up high on the motor, that will work. If you're wanting to use props where you screw them down to the motor, of course, we go down here, and now we're hitting again. So I can't get it quite low enough with all the wiring that we need to in here in order to be able to get a prop natively down to the bottom. So your alternative is going to be to raise everything up. And you'll need to raise it up quite a bit in order to be able to get the prop all the way down if you're using 1104 motors. So something to be aware of. The trimming that you'll need to do is relatively minimal to clear that. We also have a bit of a clearance issue over here, but I think if we just take 1 or 2 mils off there, we should be okay. And you can see that I've, instead of wiring in my pigtail from my ESC to my flight controller through the bottom, I've done it through the top because I had enough space, whereas with the gaps I have down here, I didn't. And of course, we didn't have anywhere to put these wires, so I just stretched them down here and then put them underneath my rubber band. Not the cleanest ways of doing things, but if you have more space in here, of course, you can tuck things up in there. I like to keep my profile down, and because this one is going to have a camera pod sitting up top, you know, we're kind of hyper exposed up there with it. You know, it's going to be about yay high, so our profile isn't terrible. But I like to keep mine down as much as I can. You might feel differently about yours. Build it as you will, but this is kind of how I've assembled it so far. Now, the next part is we're going to need to be able to tin up our pads, and we're going to need to be able to hook up our receiver on here. And that is all going to have to go down in here. So we're going to need to use some pretty small receivers. And there's nowhere on this camera that the antenna wires are supposed to come up through, so we'll have to rig up something for that as well. The main things you want to look at here as far as all these ports go is if you are using a Spectrum that requires 3.3 volt, that is out here. We've got TX1 and RX1. We've also got the S-Bus and PPM. These are for your LED strip in here. Then we've got 5 volt and ground. And then our last two are a buzzer for positive and negative. I don't plan on using a buzzer. There's just not much space for it, and it's primarily an indoor flyer. But if you're using this board for other purposes, you might be interested in that. Down here along the bottom, we've got our video in, so that will come from the camera. Then we've got our video out. That goes to the VTX. And then we've also got our 5 volt and our ground. So you can use those to power other things like your RX on there as well. Next up would be to hook up our receiver and our camera. So we're getting real close. Okay, it's the next day, and I've learned a number of things about this board. In all my attempts to bind a DSM-based receiver on this board, they all failed. Despite what the board says about itself, despite what the receivers say, I tried a bunch of different receivers. I tried a straight lemon satellite. This is that Redcon that's real inexpensive. I also tried another Redcon DSM-based receiver that's a little bit different than this. And so after spending several hours in my attempts to bind one of those, I finally decided to get one of these old Flip 32 Naze base boards. And it has a Spectrum plug right in it. And I bound it up just fine with that. So if you've got this board and you're running a DSM-based receiver that's 3.3 volt, it might work for others, but in the ones that I tried, you'll need to bind the receiver on a different board because this one, it doesn't bind through. It's kind of like the old Naze 32 Rev 6. They wouldn't also bind with a DSM-based receiver. You had to bind them elsewhere. So it's something to be aware of. The implementation with this board, it could change. So if you're watching this video much later than the published date, you may find it binds just fine, but in the instances I have, it did not. And to add to that, I have 3 of these boards, and I tried it on all 3, and they all 3 failed. So I think that's pretty conclusive. I think I probably also ought to break this out into a separate video of its own. So if anyone's out there trying to bind a DSM-based receiver to these F4s with OSDs from Banggood, that they won't struggle so much, because I spent several hours, like I said, trying to get this to work. But with all that aside, we are very, very close. I have my board rotated 45 degrees, so it lines up to where the nose is out here. I put my JST on, and now we're just down to the camera. So the next thing I'm going to do is I'm going to cut this, and I'll tin those ends up. And then those ends will go right down here at the bottom. We've got our ground right here. Let me bring this up closer. See if we can get this to focus all right. So we've got our ground down here at the bottom, then we've got our 5-volt, and then we've got our video out, which will be from the camera lens, and then we've got our video, we've got our video out, so that will be to our VTX, and our video in, which will be to our camera. So I'm going to do that. Instead of you watching me, I'll do that off screen, and then we'll come back for the final assembly. Alright, here we are in our final assembled state. We'll go through a couple things here. Because I have the video lines from my all-in-one running out, you can see how it's kind of leaning forward, but no big deal. We have this handy-dandy camera that tilts back just as far as we can like it, and you can see where I heat shrinked over the top of my antenna tube. Not ideal, but I also ran my RX antenna up in there to secure it up out of the ways. We only have so much space. I guess the other thing I could have done was run it down here. Done something along there, but you know, we make our choices and we live by them. So there's our antenna, and if you remember, this camera pod has a pretty heavy-duty, thick 3D printed piece here, so it'll flex and bend, but we really shouldn't get any damage to the top part of our PCB. Putting on the legs, you'll see that I have zip ties on here, and that secures this part from coming out. And if you build one of these yourself, the thing I can tell you to probably look for is you're going to need to do one leg at a time. You want to put the front piece in first, then you want to put the top piece on here, and then you want to leave that bottom part out until you've done all four. And it's manufactured very tight, which it needs to be, and so you're going to have to fiddle and wiggle and kind of get it going a little bit before it'll actually snap in. Don't use brute force. It will go once you get it in the right position. You don't want to be too rough on these, or you could end up snapping one piece or the other. So you kind of have to wiggle things back and forth and just kind of finesse them in. And once you get all four, the fourth one, of course, is going to be the hardest one, but once you get all four, then you just run some zip ties around here in order to secure those legs and feet in. So you can see this is our final product. I haven't decided on props yet, but I think because of my issue with the USB port sticking out and not being able to run a full 2-inch prop, that's not that big a deal actually, because I have some 1935s and I dry fitted those, and I think those will give me clearance all the way around. This wire, these two wires, my pigtails from my battery leads up to my flight controller, they concern me a little bit, but if I have a problem, I can get some tweezers out and I can secure them to the top of that connector or something like that. Of course, if that gets snapped off, the worst that can happen is I end up crashing, because these little wires are not all that valuable, nor they're rare. But these are 5-bladed props, so that should give us all sorts of thrust, and it might be noisy, but by this stage you've already seen the props that I've settled on, so that's not much of a mystery. I did have to remap my motors. They were pretty much all off. I was a little bit surprised by that. You know, I tried to hook up motor 1 to A1 and motor 2 to C2, and that just didn't work out at all. Probably because of the way this connector isn't mapped the same as this connector. And you can take these wires out and pull them and put them in the right spot to remap them. But there's if you're running Betaflight 3.1 or above, you can use the resource variable in order to remap all your motors. You have to free them up first, so you type resource motor 1 none, so that frees motor 1, and then you type resource motor 2 A02 or something like that. Joshua Bardwell's got a great video on it. I don't plan on doing a video like that because he's done a really good job. His is a little long, but I get it, and it's in there. Essentially what I did was to get to the point where I knew which motor was which. So we've got our typical motor layout here, and I would spin up each motor and then notate which one it thought it was. So motor 2 thought it was motor 1, motor 1 thought it was motor 2, motor 3 thought it was motor 4, and then I made my changes, and here's the motor mapping as I needed to correct it to. So I just typed those all in, and then now they all go the right way. I'm going to put some props on this and start flying it a bit.